Going? Perfect. Okay. So last time we were talking about still working within the inheritance model, and we were looking at public, private, and protected, right? What is the difference between public, private, and protected? What's public do?
Accessible anywhere.
Okay, accessible anywhere. What does protected mean? Inside the class, as well as children of the class have access to the members. Okay, and what about private? Only within the class that it was defined. Okay, so you studied.
I told you this is the only time I did.
All right, take out a piece of paper. No, just everybody pass it around. Just everybody write their name on it. I'll even show mercy on you. I'll give you a free quiz because I don't like being late for class. I was on a call with GoDaddy. We were doing some changes to an account, and we were about 98% done, and it was all going well. I didn't want to. We just need to finish. It was a very complex thing because it involved moving email addresses from one account to another without them losing their email. So I didn't want to. You got my text, right?
I did.
Did you tell them?
You told me.
Oh, I told you to stall them. All right. Does somebody take out a piece of paper that's being passed around?
Yep.
All right. So just get your name on that. I'll give everybody a free 100 on a quiz as an apology for being late. And since he studied and got the answers right. Actually, you got the answer right and you helped. Kind of
studied.
Well, I mean, typically you two don't know what's going on. So, I'm just saying. All right. So, we talked about public, private, protected last time. The idea being, and kind of the rule of thumb, if you will, is you should make everything private initially, and then, relax the permissions as you need. Okay? Then relax the permissions as you need. So realistically, most of the time, we will have our, what are these guys called? Fields. Okay, variables at the top level of a class are called fields. So most of the time, our fields will be private. Okay, we'll only make them protected if we have children of the class that need access to it. I would say it rarely makes sense to have a field be public because that then empowers us to do things like f.numerator is equal to blah. Make sense?
What's the difference between public and the default?
Public and the default package. See, we're doing everything in the default package, where if you were writing your own software, you could actually come up top here and you can say that this guy belongs to a certain package. And so you might have java.util.blah. And if you had it package level, it would only be accessible inside of the blah portion of that package. If you had it at the, that's the default level. If you had it public, it would be accessible across all packages. Does that make sense? Okay, so it really comes down to organization, and that only really comes into play for larger projects. Like when we import stuff like java.util.scanner, if I just do import java dot, you'll see the organization of the language is such that they created a bunch of packages, and then inside of those packages they have sub-packages. So inside java.util, we have a concurrent.atomic, concurrent.locks. We have a jar, a logging, a prefs, regex, which is regular expressions, SPI, and zip. So those are sub packages of the higher level package. So it's more of a directory organization. So packages is that. And that's what the default gives us. The default gives us permission anywhere within this package. Public will be across all packages, provided we import it. So for instance, we are allowed to use the scanner class as long as we let it know where the scanner class lives. Okay. Otherwise, if we're going to define a scanner, let's say I don't put that up there. I can create a variable java.util.scanner. Is that right? Input is equal to new java.util. That's really weird. System.in. So I can give it the full path of where that guy lives rather than importing it up top. Does that make sense?
If you try to make a new scanner below that, would it not, and you can use the java.util.scanner, would it not work then?
Okay, so you mean if I say scanner input 2?
Yeah.
It should yell at me. Equals new scanner system.in. Yeah, it's never heard of it. Because it's here looking for the import up here, where this guy just gave it the full path where it could find it. You'll rarely see this kind of syntax, but I suppose if you're only using something in one spot in your project, this is actually more efficient because when you import something, it brings that library into your executable. That makes it accessible. So why bring all this extra code into your actual executable if you really only need it one time, where you can tell it where to go find it? Make sense? Okay. So that's security stuff. We talked about method overriding last time. What is that? What does it mean to override a method? Go ahead.
When the parent has a class like display, and then the child also has one called display, it overrides the parent's display function.
Okay. Now, Nick, how lucky are you feeling today?
Not very.
Do I ask you another question, or do you end on a high? What I have highlighted right here, class method or instance method?
I think it's an instance.
Okay. Why?
Step isn't there.
Okay. We'll look at the method definition. Method definition, this is an instance method because we don't have the keyword static there. Good.
He's got
Maybe like another quiz.
Maybe I should just give him a free quiz. He's going to need them.
Start cashing them in.
All right. So, as he was saying, if we are fraction and we have a display method like this, and we have a child that extends fraction, so in this case, dumb fraction is a fraction, which means he gets a copy of everything that is inside the fraction class, including this public void display method, right? Method overriding would be us creating our own version of that display method where it does its own thing. That make sense? So that means when we have a dumb fraction and we tell, it's yelling right now because we didn't write the constructor, but don't worry about that. That means if we create a dumb fraction and we call display, it'll call dumb fraction's version of display. Now, dumb fraction's version of display can reference its parent's version of display. That make sense? It still has access to it. It didn't erase the fact that that display method was copied into dumb fraction. All it did is it made a more local copy in terms of scope. Yeah.
So the silver display will display the memory address per fraction?
Correct. Here, let me just quickly do this. I'll go ahead and add a constructor here for dumb fraction. We'll take the parameters out. We'll call our parents constructor and just pass it. What, 1 over 1 is what we were doing? All right, so now the error is gone. We'll get rid of the useless crap. So right now we have dumb fraction. Dumb fraction inherits fraction. So right off the bat, it gets everything that's inside a fraction, which means it gets 2 fields, which are accessible to its children because they're protected. It has access to the constructor, but through the super keyword, and then it gets this method, a method called display that prints out the numerator and the denominator. Okay, so if we do nothing else, I'll just go ahead and cut that method out. So at this point, dumb fraction is just an easy way of creating the fraction 1 over 1. That's all dumb fraction is in this example. Okay, if I then come out to driver and I create a dumb fraction, and notice I don't pass in any parameters because dumb fractions constructor takes no parameters. Fractions constructor takes in 2 integers. Dumb fractions constructor takes in nothing, but when it calls its parents constructor, it passes it those 2 integers. So it's hard coding in a 1 over 1. 1 for numerator, 1 for denominator. Okay, so when I come into driver, I create my dumb fraction, and then I say df.display, it's going to call that dumb fraction's display method. And we come into dumb fraction, and we didn't override the display method here. Instead, we inherited the 1 from our parent. So that means the display method is going to print the numerator followed by a slash, followed by the denominator. So we should get 1 over 1. Okay? Similarly, we could come into dumb fraction and do a public void display overriding the method we got from our parent. And this guy might just say blah. Okay, now I changed no other code. I didn't change anything over here. I'm still creating a dumb fraction. I'm still calling that dumb fraction's display method. But in this case, since we overrode the display method that was given to us by our parent, now it's going to print out blah. That makes sense? Because we overrode it. We could also say, go ahead and call my parents' version of this as well, proving that the parents' version did not disappear, still exists. And now it'll print blah and then 1 over 1. So it's executing the body of this method, and then it's going ahead and calling the parents' version of this, which will print out 1 over 1. So blah and 1 over 1. Make sense? Now what if I do this? So I created a display method, takes a string as a parameter, and it prints out that string. Out here, and that's in dumb fraction. We still have fraction the way it was before. What's going to display here? df.display. What's going to display? Well, it's going to try to call dumb fractions display method, right? What's going to display? So this would be a good quiz.
Memory address.
Why a memory address?
Because there's nothing put into that string.
Or is that just the default guess? Okay, so you think because nothing was passed in here, it's going to be a memory address? Okay. Let me give you a hint. Polymorphism. What's polymorphism? If you had to concisely define polymorphism, I'm excited about your success.
Polymorphism
Can't say it, but I can define it.
Polymorphism allows one method to have more than, can mean more than one thing, can do more than one thing. So like the display method for this thing can do something different than the display method in the other one,
Okay.
but they're both the display method.
Okay. I would say that's at least mostly right. Anybody want to add to that a little bit? Go ahead.
Doesn't it just take in has the same name but it takes in different parameters?
Number and or type of parameters. Yep. So polymorphism is when you have methods that have the same name but have a different number and or type of parameter. Okay. So in this case, we're looking at dumb fraction. We have a display method here, but we also have another display method available to us here, the one we inherited from our parent. We saw before that did not disappear. Still there, right? The difference is that our parent's display method requires no parameters. Our display method requires a string. So when I call this display method here, which one am I calling? The one that requires no parameters, as opposed to df.display blah, which calls dumb fractions version of this, right? Because now I'm calling a display method that takes in a string. So we look at dumb fraction. Do I have a display method that takes in a string here? I do. So now this will print out blah.
So parameters are a way to defeat the overriding?
Well, it's not defeating the overriding, but I suppose that's true. Yeah, I mean, because what really has happened here since we extended fraction, I'm just going to take this and I'm going to copy it in here. This is what dumb fraction looks like right now. Well, you also have a couple of fields up here that we inherited, but forget about that for a second. Right now, dumb fraction actually has two versions of display. One that takes a string, one that takes nothing. And depending on what kind of parameters we send while calling it, it's going to know which version to call. This one's going to call the one that takes no parameters. This one's going to call the one that takes a string. What's this one going to call? Well, what does it look like it's trying to call? The one that takes an int. Okay, I'm trying to pass it a 5, right? Not a char. That's the literal 5. That's the number 5. So since I'm trying to pass it an integer, notice it's not happy here. It thinks I'm trying to call a display method that takes an int as a parameter. And I don't have one of those. That's why it's an error. Does that make sense? But if I passed it the string 5, now it's happy again. Because I have one of those. That make sense? All right. So this is a class. By looking at how I'm calling it, this is a class method or instance method? How do you know?
It's using the name of the instance in which the method was.
Oh, good. You mean you're like 1,000% less stupid than you were yesterday?
How am I that?
It's like, thank you, I think.
Have you started sleeping with headphones on with the answers?
No. Actually, no.
Polymorphism. Can you make tapes like that so I can just do that?
What?
Just make tapes of all the, all the notes.
My sayings?
Yeah.
I have. That's all on video. You got the tapes.
I know, but then I gotta rip it off it so I can put it in on an MP3 player, put my earbuds in before bed, and just.
I just came up with an interesting, out of context, creepy thing to say. Last night, as my wife and I were sitting down for dinner, We wondered whether Nick was dead in my driveway. That's Nick, by the way.
Buried under the snow.
He was shoveling snow at my house. And when he finished, it was extra credit. I paid him. It has nothing to do with class grade. When he finished, he was all disoriented. He didn't know what time it was. We were figuring out how many hours I owed him money for. He was going to undercharge me. He spent 4 hours shoveling snow at my house.
Your biceps must burn.
Fingers on
I couldn't feel
So,
Be able
well, by the way,
to-
you did a very good job. I was impressed.
No
I thought it was
snowblower?
just-
Huh?
No snowblower?
I snowed my snowblower. I had to make room for my hot tub.
Yeah.
Oh.
I had one of those giant industrial snowblowers. Oh, it would have made the job so much easier.
Especially with the like 2 feet of snow you had in your driveway.
He's out there with a plastic shovel for hours.
I had to like hack away at it. Like you couldn't just like shovel it all in one shovel. You had to like dig into it.
You gotta go layer.
I was like impressed. I'm backing out this morning. I'm like, I don't know how he did this. I mean, I got like 6, 7 feet high piles that he created.
Where did he put it?
Just in the yard. So good job. I was impressed. All right, so does this make sense? So this is us calling the method. We can identify class methods versus instance methods by how we're calling them, whether we're calling them with an instance of the class or the name of the class. Here we can look at whether it has static in front of it or not to determine whether it's a class method or instance method. And that tells us how we call it. Make sense? And this is an example of polymorphism, where you have more than one method with the same name that takes a different number and or type of parameters. And the important thing there is understand that this is not a different method. Both of these are display methods that take a string. Java does not care that you named this one S and this one B. Make sense? Those are not different methods in terms of Java's eyes, just because you used a different variable name. That clear? Okay. Let's see here then. Security. Okay. Now let's start talking about data structures. Up to this point, we've created, well, we have our built-in variables in the language that just allow us to store value. What are those called? What are the built-in variables in the language that only allow us to hold a value? What's that called? Char is an example of one. What's the type called? It's some kind of type. It's there though somewhere?
Well,
Primitive
type.
types.
Yeah.
Primitive types. Built-in variables that only hold a value, right?
I thought you were talking about Hunger Games. For a
Okay.
second.
Before I saw Hunger Games, I actually thought it was about something much, much different. I guess it was the competitive eating side of me. So wouldn't that be kind of funny? You just put somebody like in this death pit filled with spaghetti and they have to eat their way out?
Jello.
I think spaghetti would be better.
I don't know. You can bounce around on the Jello. Try and swim through it.
All right, so we have our built-in variables, primitive types. All they can do is hold values. So our upgrade to that is things like this, creating our own objects. Okay? So creating our own objects, like this fraction class, is not something that's built into the Java language. But we saw that there was a need for storing variables of type fraction. which allowed us to keep track of multiple pieces of information, as well as possibly doing some additional stuff. For instance, we could add fractions together. You know, we can certainly create an add method here that takes a fraction as a parameter. So let's do this. So we're going to say public fraction add takes a fraction as a parameter, and we're going to add this fraction. Well, we're going to add the fraction that was passed in to this fraction. So if we're going to go ahead and do the magic for this. So how do we add fractions? We have to get a common denominator first, right? So we're going to say int common denom is equal to this dot. Well, what's the brute force way of getting a common denominator? Multiplying by each other. Okay? So we're going to take our denominator, this dot denominator, and we're going to multiply it by f's denominator. Right? How do I get to f's denominator? Huh? F dot denominator? Tell me why that won't work. Besides the red underline.
Super dot denominator.
Well, F isn't super. F was the parameter that was passed in.
Fraction dot f.
And here, just to make this even clearer, and so I'm pointing you in the direction here. Notice I'm changing protected to private. Both of them are going to have the same effect here, but in the real world example, this idea of dumb fraction doesn't really make sense, right? Okay, this guy doesn't exist. We just created the concept of a dumb fraction to explore inheritance a little bit. So I disconnected dumb fraction from our world. We'll just dump that real quick. All right. So now we just have fraction, and fraction has two fields that are both private. And I've advertised that we should probably make things as secure as possible, correct? All right. Now I want to create a common denominator here. I'm going to do that by taking this dot denominator, which is the denominator owned by this instance of fraction, and I need to multiply it by the denominator associated with the fraction that was passed in. How do I do that? Okay. Well, I'm inside fraction here. How do I access the driver class? Who's the parent of this guy? Super is what? Who's the parent of this? It's not driver. Driver is the guy that created its instance of fraction. Right here. Parent's object. Okay? Remember we had our guy right here? So now we're back to this model where we took dumb fraction out of the equation. So fraction's parent is object. So super doesn't give us anything because object doesn't have a denominator field, right? I'm asking you to problem solve like people. And here, let me just take that stuff out since we're not using dumb fractions anymore. We can access this particular fraction's denominator by saying this dot denominator. We were covered with that, right? But now I need to get at f's denominator. Why can I currently not access f's denominator?
Because it's private at the top.
Because it's private. What does private mean?
It's going to the same method.
It's only accessible within this instance of the class. Okay, only accessible within this instance of the class. So by saying f dot denominator, we are not in this instance of fraction.
So change the private to public.
Protected. Protected.
Change the private to public.
You want me to make it public? That would work. Making it public would work, but wouldn't that be bad programming? We've kind of advertised we want to make it as secure as possible, right? Now, actually, right now, I'm actually halfway lying to you, but I want you to stumble upon something. Go ahead.
What about public fraction? Change it to
I want you to come to a conclusion of something that I haven't necessarily shown you yet, but I've given you everything you need to know you need it. I have made these methods, or these fields, private. Okay? Assuming it's private, how would I access the private members of a class?
Could you make a variable and then set it equal to that field, that private field, and then access that public variable through that function?
I would say what you're saying is not, it's doable, but keep in mind you're only going to get the value of that public field once. Because if what you want to do is he wants to create a public int blah, and then after we set the enumerator, then he wants to say blah is equal to this dot. Well, I guess in this case we're dealing with denominators. This dot denominator, like that, right? And then we could access blah directly because we made that guy public. The problem with that is these guys are only linked at the very beginning. If we ever change the numerator again, blah will not update with it. This is literally resolving the current value of denominator and placing it in blah as a one-time gig. Now, to take that a step further, kind of going with your logic, could I, though, create a public method that returns an int called getDenominator that returns this dot denominator? So in this case, I have a private field, and I've created a method that gives me read-only access to that private field. One of the reasons we want our fields to be private is so that people can't go in external to this and do something like hard code in a new numerator by changing it directly like that. But now, another reasonable way of using a public numerator might be just to say f dot numerator. We want the value of that guy. Getting the value of it doesn't really do any harm, right? We might decide that having the value of the numerator might be helpful external to this class. But allowing them to directly change the numerator maybe is something we don't want to happen. So what we do is we make the fields private. And then if we need to give read-only access to those fields, we can create a method that gives us access to a private member. Does that make sense? This method right here would allow us to say f.getDenominator. And this would get the value of denominator. But it would not allow us to set the value of denominator. We couldn't change it. Does that make sense?
Did you make that equal to a new variable?
Okay, I'm glad you said that stupid thing. Knew I could count on you. So you want to do that?
Back to the old.
No, make it a variable. So like it's a equals that.
Like this?
Sure.
Okay, fine. So now I have a variable, but if I say denom is equal to -7 here, that changes this local variable denom, but it doesn't modify the global. It doesn't modify that fraction. Okay, the reason is at runtime this will resolve to its value. In this case, the denominator is a 2. So at runtime, this is the same thing as saying that. There isn't this magical link back to the class. Does that make sense? So putting that 2 into a variable called denom, then changing denom to something else will not have an impact on f. There's not like a permanent, it's not a pointer. It's a copy of the value.
And still give us access to that number in order to manipulate further. I mean, it doesn't
Sure,
change the original.
and generally speaking, we're okay with giving access to it. You know, read only, being able to get the value of something typically is not that important unless you don't want, like for instance, you wouldn't want somebody to be able to publicly read your credit card, correct?
Don't go to Target.
But you definitely don't want somebody to be able to publicly use your credit card. Or let's do the modification related to this. We don't want them to be able to change our credit card balance, probably making it go up by spending it on crap, right? So for us, our credit card number is a relatively private piece of information, correct? You mean, you know, not private to, you know, the point of being crazy. I mean, you probably have sent your credit card information over an email to somebody before. If it's somebody you trust, that they'll delete the email afterwards or something like that, or, you know, you're getting with a couple of buddies who are, you know, doing a Netflix subscription and, you know, you're the guy whose credit card information is going on file or something like that. We could see that doing that with friends.
Paid for honor, buddy.
Right? Yeah, something like that. We could see that doing that with friends, sending an email over, or credit card information over email. But certain things we wouldn't, right? For instance, would you send the password to your bank account via email, even to a friend? We consider that to be more secure, right? Giving them a credit card number, you have a way of seeing if they're misusing it, okay? But we consider both of those to be fairly private information. So realistically, if we have to check a box, is our credit card number public information? We'd say no, right? We hide that, okay? So we would make our credit card number, if this was credit card number, we would make it private, and we would not create a method for accessing that information. It's only for our internal use. We only have access. Okay, this instance of human who has a name, a social security number, a credit card number, only I have access to that credit card number. Only I have access to my passwords for my various accounts. Does that make sense? These aren't public pieces of information that you guys can go and retrieve. You can't update my passwords. That would suck, right? If I'm walking around and you have public access to my password, but it's not just read only, it's read write. And also the next time I go to log into my email, I can't log in because, you know, Nick over here changed my password on me. Okay, we wouldn't like that, correct? So different pieces of information we want to give different security to. Passwords we want to keep private, not read only, not read write, for our eyes only. Credit cards as well. But in this case, for a fraction, we might decide, you know what, the numerator and denominator, we don't mind if somebody sees those values directly, right? No harm, no foul. Like this is the fraction 1/2. You want the numerator? It's a 1. You want the denominator? It's a 2. But I'm not going to let you change this fraction without me knowing about it. Does that make sense? That's why we would make it private here and then give it a little bit of public access that we control. We are allowing them to get the value of the denominator, but not change the value of the denominator. If we wanted them to change it, we might say public void set denominator like that. By putting these two methods in there, we might as well have made this guy public. Because we just wrote fancy methods that allow them to get the value as well as set the value. Why not just allow them to just get it and set it directly through the variable name? Does that make sense? All right. Now, having said that, let me ask that same question again. I said, why not just allow them to get it and set it through the variable name? Could you give me an example of when we'd want to make the variable name private, but let's say we do want them to have read-write access to it? And we do want them to have read-write access to it, so we would provide them with a method to get the value and another method to set the value. Why would having methods to get and set the value be preferred over just making this a public variable that they can get and set at their will? Can you give me an example? Specifically in fractions, I think we can come up with a good example. Why we'd want them to make changes through a method rather than directly.
So they can't alter the whole thing. That way, in case you want to reverse it, it's not such a problem.
Give me an example of a bad fraction. Something that has a 0 in the denominator is considered to probably not be a great idea, right? We start getting divide by 0 problems if we start doing math with that, right? So would you agree that giving somebody the power to just directly set the denominator to 0 might be problematic? But if we force them to use a method to set the denominator, couldn't we say if new denom is not equal to 0, then we'll let you set it. Otherwise, we have protected the denominator from ever getting set to 0. As an example. So you see the difference here? By me making denominator public, they can set it externally to whatever the heck they want. They get full reign without us having any checks and balances. By making them use a method of our design, we can choose to add some protections to make sure it doesn't get into a bad value, doesn't have a bad value. Does that make sense? Okay, so this still supports this idea of make your fields private or as private as possible. And as I said earlier, I cannot come up with a good example of of making a field public. I would say fields should always be private or protected. To make a field public would have to be a very, very specific situation, or you're just throwing something together really quickly to solve a problem, and you're the only one who's going to be using it, and you trust yourself that you'll not manipulate the variables in the wrong way, and you just don't want to spend the time writing a couple of methods. So I could see that argument if you're not creating code that's going to be reused or given to somebody else. You're just slapping something together to solve a quick problem for yourself. But generally speaking, fields should always be private or protected, and then if we need to give access to them, we write methods. This type of method right here, this get denominator, historically would be called an accessor method. We are giving access to a private member. It's called the security methods. Well, here, why don't we say gives more public access to a private or protected field. And then we actually add a little more to that. Gives more public read access. Because that's for read only. So the example here for our accessor method is this guy right here. Get denominator. All they can do from this is retrieve the value of denominator. They can't alter it. Well, they can't alter it within this instance of fraction. They can capture it, as Nick was saying, in our own variable here, and then change that variable. But that will have no impact on our fraction. So we're not allowing them to modify our fraction externally through an accessor method. That make sense? Okay, so accessor methods would kind of be the old style way of calling this. So this would be what they used to call these methods in like the C++ programming language. The more modern terminology for this is something called a getter. So accessor methods are getters. They allow you to get the value of a private or protected field. Make sense? The other one is a mutator method. This gives public right access to a private or protected field. So a mutator method allows us to change the value of a private or protected field. Mutate it. So our example of that would be right here. This is a mutator method. Back up there. Our accessor method is a getter. Our mutator method, modern terminology is it's a setter. It allows us to set the value of a private or protected member, private or protected field. That makes sense? So proper object-oriented programming is to lock down the fields, the global variables of your objects, and then give access to them at the appropriate level through getters and setters. That's the appropriate way of doing it. Make sense? All right. So that's where these guys come in.
What exactly is it providing security for? People who are editing, or?
Well, somebody who's using it. So for instance, you know, out here before we used the scanner class. And we'll go ahead and import java.util.scanner. Okay, we did not write this guy. Somebody else wrote that class. And that class probably has some private members in it, right? So if I say input dot, this is showing me what I have access to, and none of those are variables. They're all methods. Now let's just do a get. So for instance, I can get the class of an object. This actually came from the object class, because all scanner probably imports from java.io, which imports from, which inherits from object. So the top level object gives us the ability to ask it its class, but it does not allow me to set anything. So in this case, our scanner is allowing us to know what class it is, but not allowing us to change what class it is. That make sense? Okay, but this would be the good example where we don't have control of the original object. In our example here, we're writing the fraction and using the fraction. Okay, when we make these security decisions, what we're really thinking about here is, well, there's two levels of what we're thinking about here. Number one is we're trying to lock it down enough so that it's easy to use by anybody else who we give this code to use fractions. Make sense? Just like the people who wrote the scanner class, when they handed it to us, they made it so that we couldn't get into trouble. All right, when you know, when you go to Home Depot and you buy a chainsaw, you know, they've put reasonable safety precautions on the chainsaw to keep you from cutting your fingers off. They still have to expose some dangerous parts, but at least the motor is encased in some sort of whatever, and they give you the little handles so you're not just holding on to this hot machine where you're burning your hand on the carburetor and stuff like, you know what I'm saying? Okay, so you know they have put necessary protections on the device, only exposing the aspects of it that have to be. Okay, so it's that kind of idea. That's number one. Number two is by making this stuff private even for us, we give ourselves our own sets of checks and balances so that we don't make a stupid mistake. I mean, we all make mistakes. It's entirely possible that we might have meant to say one thing, but because of auto-completion and stuff like that, we actually typed in something else. And because we had our security set at something, we might modify the value of our fraction unintentionally. Does that make sense? We modified unintentionally. And if that's the case, well, now we have a problem. So by being good programmers, even when it's only us using the code, that keeps us from getting into too much trouble, because at the very least there's checks and balances. This argument will come back up later on in the course when we talk about something called interfaces. Okay, interfaces, just the quick punchline there, they allow us, so in an interface we might say implements runnable. Okay, runnable is an interface that's built into the Java language. All right. Now, by saying this guy implements runnable, in fact, I'll just teach you interfaces right now. Notice we have an error now. It's going to say we must write a method called public void run. Hover over that. So type fraction must implement the inherited abstract method run. An interface is a way of defining the things that must be included in a class. So we have this thing called runnable. It's actually used by threads, multi-threading model in Java. Who cares? They wrote this interface, they named it runnable, and inside of this interface they said anything that implements the runnable interface has to create a method called run, or we will scream at you. Does that make sense? Now, couldn't we have just self-policed ourselves and said, well, fine, I'll just write my own run method. I'll do it anyways. I don't need somebody yelling at me. Okay, but if you haven't worked with the code in a while and you start making changes, you might wish that you had that thing up there, because if you change that run method to be called something else, that guy will remind you that you were forced to put in a run method for a reason. Does that make sense? So creating interfaces allows us to create our objects that meet a standard. So if you ever go into like a grocery store and they have those UPC scanner things, okay, there's probably, I don't know, probably 10 different companies that make those devices. And each one has their own kind of unique features, but they all have a subset of features that are consistent across the board, because there's a standard of how UPC codes are scanned and cataloged. There's a standard set of information that's included. Does that make sense? Okay, so whoever built those, at the very least, had to adhere to this core standard that all of them must have. And then they can add the bells and whistles that make sense for, you know, why somebody should buy their product versus somebody else's. So this is a standardization tool. That make sense? Just more policing of your code to help us keep us from getting into too much trouble. If you're creating a whole bunch of objects that have to do a certain type of network connectivity, and every single one of them has to convert their data structure into JSON format, a data type format, and then they also need to be able to receive something in JSON and turn it back into a data structure, you might require all of your objects to implement two methods, encode and decode, or make JSON, decode JSON, or something like that. Okay? You might decide every one of my objects has to have this. And by doing that, if you just by default, you make every one of your classes implement that interface, and you can have them implement multiple interfaces. But if you have every single one implement at least that interface, it will scream at you if you forget to write one or both of those methods. So it's kind of a self-policing thing, because as our projects get bigger and bigger, there's going to be more, you know, we're juggling more balls in the air. It's going to be hard for us to remember all that stuff. Maybe an important thing of this is with interfaces, a class can implement multiple interfaces. A class cannot inherit from multiple classes directly. So what I mean by that, and let's actually just create a slide real quick that says that. Let's call this notes. A class may implement more than one interface. A class may not, this was supposed to just say implement, inherit from more than one class. And what I mean by that is, let's say we have this guy here. Hello. I'm doing a lot of strange clicking today. So let's say I have two objects I've created, a car and a plane. And both of those inherit from object. Perfectly legal. Okay, so I created a car class, he's an object. I create a plane class, he's an object. Okay. Now I'm going to create one of those, the flying cars. So here's my flying car class. We cannot have a flying car inherit from both car and plane. Doesn't work. This is called double inheritance. Java does not support it. So we cannot make flying car get everything that's in car and get everything that's in plane like this. Okay? What we could do is we can say a car is an object. A plane is a car with wings. A flying car is a car with wings that maybe has some extra things in it as well, like a button that makes the wings go away, or something like that. Make sense? So we can accomplish a flying car being both a car and a plane this way, but we cannot accomplish it this way in Java or C#. So these guys do not support what's called double inheritance. All right. So class may not inherit from more than one class, double inheritance. But we can implement more than one interface. So if we have to adhere to the UPC scanning standard, as well as maybe the Wi-Fi standard 802.11. Okay, so we might have an object that needs to adhere to both of those standards because it has to do Wi-Fi stuff. And it also has to do UPC scanning stuff. And those both have standards, right? Okay, kind of makes sense? What implements does versus what an interface is versus a class. Okay, an interface does not dictate what those methods have within them. It does dictate their name, their return type, and their parameters. You must create a method named this that takes these as inputs and produces this as an output. You get to now write the magic to do that. Okay? So for instance, with runnable, the run method returns nothing, void, and takes nothing. So if you really, really want to be lazy and you had something that implements run, you could just write a method called void run, takes no parameters, and does nothing. Open curly brace, close curly brace. Maybe you put a little comment that just says lol. Make sense? Okay, so that's that model. All right. So we talked about getters and setters. These give us public and private, these give us more public access to private and protected members. It gives us control over who has access to them and what kind of access they have. Rather than us at this level having a no control over what kind of value somebody might put in there if we open it up to change. So we're giving them direct access to the variable. We would let them set the denominator to 0 because we're not given an opportunity to check what value they're entering. With a setter, we are. That make sense? Cool thing, let me get rid of our setter and getter here. Cool thing with a tool like Eclipse, which is an IDE, integrated development environment, it's a super text editor that does some extra crap for us. For instance, when I say, if I have a string and I say s dot, it shows me all the things that can display, right? Another cool thing that this does for us is notice I have two private members here, right? Two private fields. I can come into Eclipse, right click, go to, I think it's under source. Then down here, generate getters and setters. Click on that, it'll bring up this little window. And you can hit the drop down on these if you want. You can choose to make all of them a getter and setter for both of these, or maybe you just want getters for each of those and not setters. Make sense? So in this case, I just want to make getters for both numerator and denominator to let external entities have access to those values without changing them. Make sense? So I'll go ahead and do that. We'll hit OK. You can choose what access modifiers will make them public because we want to make that publicly available. We don't care if you know about the numerator and denominator. We just don't want you to directly change it. So we'll hit OK, and it'll go ahead and create those two methods for us. Make sense? That's a perk of an integrated development environment. It does stuff like that for you. If I add some more private members up here, I can just go back through and do that same thing again. It'll go ahead and generate the methods for me. Okay? So more of a reason to make everything private because it doesn't mean you have to write a whole bunch of extra code. A couple of clicks and you have your methods written. Right? So now we're back to our add fraction here. So the way I get at this denominator is by saying this dot denominator, that's the guy up here. The way I get at f's denominator is by saying f dot get denominator. Then our semicolon there. That make sense? Okay, remember earlier I said I'm kind of partially lying to you? Remember when I said that?
Mm-hmm.
I left the semicolon off. The semicolon is what was given the error. Okay? Yeah, I heard you say it. I just ignored it because I didn't want to show my hand yet. All right. Tell me why this works. I really wanted to show you the lesson I just showed you about accessor methods, getter methods.
Isn't it because you're using the instance?
Denominator is a private variable. What does private mean? It's accessible as long as you are inside of the fraction class. Am I inside the fraction class? Am I inside the fraction class? Yep. Since I'm inside the fraction class, I have access to the private members regardless of whether I'm dealing with this's denominator or f's denominator. Does that make sense? So in this particular case, I actually didn't need our getters. But we at least had the opportunity to introduce what getters and setters are. Make sense? So this is my common denominator. It's my numerator. It's my two denominators multiplied by each other. Then we need to get our new numerator. And our new numerator is going to be this's numerator times f's denominator plus f's numerator times this's denominator. It's our cross multiplication thing. That's going to be this's numerator times f's denominator plus this's denominator times f's numerator. I'll just kick this down a line so we can see it all. So that's my new numerator, right? And then I'm going to return a new fraction. And our constructor for fraction takes in a numerator and a denominator. And we've advertised that this method's going to return for us a fraction. So I'm going to return a new fraction with new numerator and common denominator. Common denom. All right, that makes sense. You on Papa John's list as well?
Mhm.
Are you?
Yeah.
You just got the Papa John text? I'm thinking that's maybe it was like some AT&T warning or something. No, pizza coupons. All right.
Story of my life, pizza.
So now what I can do, now that I've written that, I'm going to get rid of the implements runnable thing. That's what it's complaining about right now. I can go into driver, and I can say fraction 1/2. I can say fraction f2 is equal to new fraction 1/4. Fraction f3 is equal to f dot add f2. And then I can say f3 dot display. And there's 6/8, the two fractions added together. Now let me ask you this. If I say fraction f4 is equal to f2 dot add f1, and then I print out f4, what will output here?
Why did you change it to F versus
Oh, thank you. There we go. Now what will print out here? Exact same thing. So we'll get 6/8 twice. But we did two separate things. In this case, we asked f to call his instance method called add and pass in f2 as the parameter. So in that particular call, this was a pointer to the same thing that f points to, and f was a pointer to the same thing f2 points to. In the second call here, where I told f2 to call his add method, passing it f, in that particular copy we had this being a pointer to the same place that f2 points to, and we had f being a pointer to the same place that f points to. They both accomplished the same thing, but we had a different one of these instances call his version of the add method, passing the other one as a parameter. So we got the same result because f plus f2 is the same thing as f2 plus f. Make sense? All right, I will see everybody on Thursday. We might have a quiz on Thursday. And we got the sheet. Okay. All right, see everybody then. Reminder, Bible study today. Cafeteria, get free lunch. Sign your name thing. I'm going to head down there now and eat in the cafeteria, then head down to Bible study. But it's from noon to 1 in whatever that auditorium is called. Terrace room.
Fraction.
It's in the terrace room.
I require your signature so I can